All right. Hey guys. So I'm actually really excited about this lesson because I feel like this is going to be one of the first ones that you're like, wait, what? Which is actually really exciting. um, and yeah, because I know a lot of you are like, you always want to learn more and you're always so on it. So like, I feel like this is going to be one of our first things that you genuinely, I'm like, oh, I didn't know that. Okay, that's cool. um, so this plays off of everything we've talked about triangle relationships. We talked about perpendicular bisectors. We've talked about mid segments. And so we're going to look at like almost relationships of relationships in a triangle. Obviously, you can tell I'm really excited about math. Anyways, so today we're going to learn about something called the circumcenter of a triangle and the incenter of a triangle. They're kind of similar ideas, similar to how we had the perpendicular bisector and angle bisector. They're related to each other, but kind of different. So the circumcenter is the perpendicular bisector of all of the sides of a triangle, and they intersect at a point called the circumcenter. So here's my perpendicular bisector that goes through AB. So D is the midpoint. It goes exactly perpendicularly. I have PE doing the same thing here and PF doing the same thing here. So this point that they intersect at the center is called the circumcenter. So it's always equidistant then from all of the vertices of the triangle. Here, wait, let me color code it. So it's the same distance from here, and here, and here. So many relationships happening. So just to kind of wrap our heads around it, all the perpendicular bisectors, like we said, I labeled in green. They're created from finding the midpoint and creating a perpendicular line there. So my perpendicular bisectors are PF, DP, again the order doesn't necessarily matter, and PE. The circumcenter would just be P. Wow. P. And then there would be a lot of congruent segments here. AD, oopsie, is congruent to DB. And again, that was kind of established when I said D was the midpoint and we created that perpendicular bisector. We also have BE and EC. We have AF and FC. And then kind of our newest discovery today is that all of these, the distance from the circumcenter to the vertices, I guess 4, would be congruent as well. So that's AP is congruent to BP is congruent to CP. All right. So essentially what this creates is a bunch of right triangles. So looking at number 1, since this point right here is the perpendicular bisector, I know this is a right angle and this is a right angle. Same thing here and here. Because I have a bunch of right angles, what I technically have is a bunch of right triangles. So today we are going to be heavily reviewing Pythagorean theorem, which we've kind of like touched on a lot through the year and we've incorporated it in a lot of the things that we've been doing, but this is the first time that we really need to like explicitly use it. So it wants me to find all of these pieces of the triangle based on the information that I'm given. So there's a lot. Okay. So if it wants me to find the distance of TU, that's that entire thing. So this piece is 19, meaning this piece would be 19 as well. So that entire thing would be 38. I'm going to erase as we go so you can like kind of see everything. Okay. VY is the next thing it wants me to find. If this entire segment is 34, then VY must be 17. UZ is this segment right here that connects the circumcenter to the vertice. Again, if I know that this is the circumcenter, then the distance to all vertices would be equal to each other. So if this distance right here is 21, then my other distance from circumcenter to vertice would be 21 as well. Okay. VW is right here. This is the fun part. Okay. So I have my hypotenuse. I have a leg. I need to find my other leg. So that would be a squared plus b squared equals c squared. So b would equal 14.7 about. All right, TV would be right here. So if this was 14.7, that point W was my midpoint, so all of TV would just be double that. Should be 29.4. All right. I will do one more circumcenter one with you, and then we'll move on to the incenter. I'll just do number 2, I guess. All right. So GD is right here, connecting my circumcenter to a vertice, and I know that the distance from all vertices to the circumcenter is the same. So if B to H is 13, then I started with the wrong one. Does it ask me what? It doesn't even ask me what DH is. Hello. GD. Oh, it wants this one. That's even easier. All right, so if the entire distance from B to D is 24, then GD would be 12. BC is right here. So if EC is 7, that must mean this is 7. So the entirety of BC would be 14. Okay, EH is a perpendicular bisector here. Oh, we already said this was 7. So here's my right triangle. And what I'm really missing here then is a leg. I know I'm going like kind of fast, but most of this is review. Pythagorean theorem is review. After we set up the equation, like the rest of all of this stuff is kind of review. And so the nice thing about this too is that you can, that's approximate, but about 11. You can pause, you can rewind, you can rewatch things. I'm trying to color code but I know you guys just really want to get to work. All right, 2 more. The next one that they want me to find is FD, which is here. So now is where I know that the distance from the circumcenter to every vertex is the same. So essentially I have another leg. I'm missing this leg, FD, but I have the hypotenuse. So B would be approximately 12.6. So this would be 12.6. If they want me to find C, D, I would just have to double this number, which would give me 25.2. And again, like I said, I'm going through this quickly because I know a lot of you will just be able to pick up on it. But if you can't, or if you still have questions, like I'm in my Zoom room for the entirety of our class period. You can come in if you need to. But if you feel comfortable, just go for it. All right, so this brings us to incenter, which I said is very similar to the circumcenter, where circumcenter is where all of the perpendicular bisectors meet. The incenter is where all of the angle bisectors meet. So it's always equidistant from the sides of the triangle. So there is a difference, and it's just going to take some practice. So here, all of my angle bisectors then would be cutting this angle in half here, right? So line AP is an angle bisector, CP, and BP. The incenter would just be point P. And so all of my congruent statements then would be that if this was my angle bisector, then this would be congruent to this side. So line FC is congruent to line CE. For this angle bisector, that would mean line BE is congruent to line BD. For this angle bisector, DF, line DA is congruent to line AF. And then because it is the incenter is equidistant to every side of the triangle, I would know that line DP is congruent to line EP, which is also congruent to line FP. Again, I know it's a lot. It's a lot to process, but none of it is too difficult. It's all just about the practice. Okay. So if P is my incenter here, to find NP, which is this one, I know that the incenter is equidistant to all of the sides of the triangle. So they would all have a value then of 8. Right. Looking at NK right here, because this was an angle bisector, I know that this line segment would then equal this line segment. So NK would be 17. So for the last two, we're going to need to go back and rely on our Pythagorean theorem again, because what I've essentially created is a bunch of right triangles. So this next one wants me to find PK, which is my distance right here. We already said that this was 8, so I have both legs of a right triangle. I'm just missing the hypotenuse, which would be PK, which is what I'm looking for. So this would give me 64, 1, oh gosh, I'm blanking. 17, 170, 187. No. So 353 equals c squared. X, or c, would be about 18.8. Alrighty, again, for LO, which is right here, this time, what I'm missing is one of my legs, because this is my hypotenuse. So I have 8 squared plus my other leg squared equals my hypotenuse squared. So 64, 169, b squared would equal 105, or about 10.2. Alright, so I'll do number 6, because that one understandably looks a little bit funky, but again, it's all just about labeling everything that you have. So it says if S is the incenter, angle PRQ, so PRQ, this entire thing, sorry, I got a phone call in the middle of recording my video, but anyways, so I've labeled all of the angles that were given, and I'm going to work from here. So since I was given 3 angles, and this is a triangle, all I'm going to do is just set up an equation and set all of these equal to 180. That way, at least, I can solve for x. Once I do that, then I can plug it back in here. So 8 times 11 would be 88, and then minus 10. This entire angle is 78. So let's see, 77 minus 5, this would be 72. And then 44 minus 14, this would all be 30. So then I can answer these first 3, PRQ. PRQ would be 78. RPQ would be 30. PQR 72. And then within that, now I'm going to start including my incenter. So RPS, that's this one right here. So I know that that's half. That was my angle bisector. So that would mean that that portion was 15. PQS, again, now I'm including my incenter as a point, because then I can infer that this was a bisector here. So half of 72 would be 36. PRS, so this one right here, angle bisector, so half of 78 is 39. Now, I'm gonna, let me see, erase as much as I can here. Now it's asking me for PSR. So that is this segment, this portion right here. So I already figured out that PRS was 39 and that RPS was 15. So because that forms a triangle, I want all of these three angles, I'll call this just S, I want them to add up to 180. So let's see, that would be 49, 54. So S would equal 126. Alrighty, so for the rest of class, I would like you to work on odd. So it sounds like a lot, because it'll be, but that's all just basically one problem. You're finding MN, you set those equal to each other. Again, these look overwhelming, but they are not that bad, as long as we understand the relationships within them. So as always, I'll be in my Zoom room for the whole class period. Please check in. If you have a question, I'm even happy to hop into your OneNote to make sure that you guys are doing it correctly and didn't make any mistakes. But use me. I'm a resource, okay? Good luck.